Today I'm going to talk to you about exotic Phytophthora species that are being systematically introduced in California wildlands during restoration projects. You know, I really hope with all this awareness and outreach that has been done over these past years, that's changing, you know, we're changing this story and moving it in a more positive direction. I noticed that everybody put their acknowledgement, a lot of people were putting their acknowledgements first. I really like that, so I moved mine up as well. You know, there are so many people that I work with on these projects, and it's so great to see your faces again. Susan Frankel, Steve Cheswell, Dave Chambers, Cameron Chi, who's a phenomenal undergraduate for Pathology. If she stayed in that, we would be so appreciative. She's probably going to go on to be a great medical doctor or chemist or something, but she did a ton of the genetic work with me, and also, you know, managed a lot of the isolations. Doug Schmidt and Tina Popinik did a ton of the work. You know, Golden Gate National Parks, National Park Service, that's the PUC, is the City of Trust. You know, it was a lot of work, not a ton of money, and we made it happen. And so it's really great to see these pieces come together. And I'm so glad to be here. So I don't really have to talk to you guys too much about, you know, why we care, but I just want to emphasize it over and over again. You know, exotic Phytophthora species are a serious threat to wildlands. They reduce this resource and the health of our forests and wildlands, and we really need to take them seriously. I think gone are the days of saying it's okay to introduce Phytophthora. It's not. And I think we must actively manage to prevent introductions into wildland areas. So for my field sampling approach, I looked at 3 different types of pods, so planted, restored sites, unplanted, apparently low impact sites. Doesn't mean that nothing ever happened there. They may have had a history of use, but they were away from trails and roads. There wasn't any obvious stream inundation associated with the restoration. And then areas where it was obvious, you know, this is right next to a trail, or it's right below a trail or a road. Or I could say, okay, look, there's a stream right here, the restoration's right here, the stream overflows seasonally into the restoration. So very obvious impacted areas that weren't necessarily planted. So I collected samples from upland and lowland areas where possible. Sometimes you don't have a lowland area right adjacent to an upland area, but I did that where possible. And then I compared my results to nursery results. Most of the data came from a few locations in Marin County, San Francisco County, and San Mateo County. I'm also going to talk to you a little bit about a project where you know, I worked with Tyler Moray as well and used his data, and I put together a bunch of isolates of one particular species, and those also came from other locations, Alameda County, Monterey County, and Santa Cruz as well. So I found overall that isolation success was highest from 3 plant species. So Diplochus aurantiacus, so sticky monkey flower, Ceanothus thyrsophloris, so blue blossom, and Fringilla californica, or California coffeeberry. So growing in restoration sites and in adjacent disturbed sites. Phytophthora crassinura was particularly interesting. I think it's a pretty fascinating species in general. It's a clade 6 Phytophthora. A lot of the clade 6 Phytophthora we think about as in the water, but in this particular one, you might have even noticed, I think it was in 10 slides, you found this at drier sites as well, and also ones where you only have seasonal water inundation. So it's a clade 6 that's moved away from streams. And it was always more abundant 2014. So it's a pretty new Phytophthora on the scene, and it was always, it was way more abundant than the older species was that we had known about before. It was found quite frequently, so it was found in 13 restoration sites across 6 counties. So this is, you know, putting together work for both me and Tyler. So what do plants look like when they have Phytophthora? You know, I was hearing people saying things like, oh, they, you know, sometimes we find them from apparently like healthy looking plants. So when I went out and sampled, I sampled healthy looking plants, and I sampled plants that look terrible. You know, I just went across, I said, okay, I'm going to sample these plants and see what I get. And what I found was that healthy plants did not have Phytophthora, and the ones that looked crappy did. So it was really apparent, you know, when the plant is senescing late in the year or losing foliage or something like that, I thought, you know, is Phytophthora there? Is it part of these natural processes? And the answer that I found was no. It is not in those plants, but it is in plants that are dying and look awful. So, for example, here's Upland Diplicus orontiacus. The one on the left side there was negative. The one on the right was positive. Again, so some more very healthy Upland Diplicus orontiacus in good shape, and the other ones that you may barely be able to tell on there. So, but there's a tiny little bit of green foliage on the top, and if I went down to the base of the stem, I could find some little sprouts, a little bit of green material there as well, and I could actually find the canker margin, and that's where I could isolate the Phytophthora from. So I could get it directly from the plant itself. So here we've got some uplands, you know, this Thyrsophloris. What's interesting is it looked like the plant actually, this is in a restoration, it looked like it grew out, it kind of established itself at that site, and then it died back in this particular instance. That wasn't always the case, it was here. But this is the stem of it, and then I could isolate Phytophthora from the canker margin. Here's an example of lowland Framula californica. So this area where you get seasonal water inundation. In this case, I didn't have cankers above ground. The growth was just very stunted and chlorotic. And then I could isolate, you know, multiple Phytophtheras from the base of that plant. So what were the pathogens that I found in restored, impacted, and unrestored, unimpacted areas? So by far, the restored areas tend to have more pathogens, not a ton more than the impacted areas, but a little bit. And then, you know, I still was finding pathogens. I was still finding plants that looked sick in control areas, but I wasn't getting the Phytophtheras from those control areas. So I did find Fusarium in there. I found some mock canker fungi. I did find some Pythium species or Globosporangium, depending on what you want to call it, in those areas. But I did not find Phytophtheras there. So, and you can see that the number of Phytophtheras that I was finding were more in the restored areas. So upland versus lowland. So I only found Multivora in the upland areas. I found several species across both upland and lowland areas, and then there were a couple that I only found in lowland areas. For Phytophthora multivora, I'm not convinced that it's any sort of biological thing because I actually didn't have lowland areas to sample that were associated with that, so it could just be by chance you know, that I didn't collect that one there. However, it's possible that inundata may not survive in upland areas, or perhaps in wetland areas that have actually been kind of naturalized in these systems, because I found it quite a bit in those lower areas. Also possibly P-taxon raspberry. I was finding it in those lowland areas, but not in the upland ones. Okay. So then I took, so I did nursery did 26 samples, 20 of those were from nurseries, and 106 were from wildlands, and I found a lot of overlap there. So from both nurseries and wildlands, I found Phytophthora pseudocryptogaea, Phytophthora texan-kelmania, and Phytophthora crassimura. I only found megasperma in wildlands. You know, it's kind of an older species. It's one that's been on the scene for a long time. Perhaps it's, you know, from a very old introduction, so we're not really introducing it as much anymore. Of course, I didn't have a ton of nursery samples as well, so, you know, maybe I just wasn't capturing that. And then I actually had, what I'm calling Phytophthora texan-kelmania type 2. It's, you know, that's my name for it. It was a kelmania that I only found in nurseries, but I didn't find in the wildlands. For coffeeberry, I had a lot of overlap as well. Again, you know, you see this crassimura in both nurseries and wildlands. I had Phytophthora in both, and pseudocryptogaea, and then several species that, you know, I only found in wildlands and a couple in nurseries only. And for blue blossom, I found Phytophthora multivora in both of those systems. So then I took, I wanted to look at the genetics and the phenotype to determine the origin and spread pathways of these Phytophthora. So, you know, while we learned, you know, in this symposium about some of the rapid ways we can look at like whole genomes and all this stuff, for me it was still a very slow and tedious process. So I really just focused in on Phytophthora crassimura and did an in-depth study on that because it was a species, you know, that I'm finding in both nurseries and wildlands on a pretty regular basis. I was finding it in restorations all over the Bay Area and across several nurseries. So it was very, it seemed very, very important. So I looked at the size of the DNA, the oogonia, DNA sequences, and also sensitivity to methanoxam. And really why we were doing this is we were, you know, looking at this and saying, okay, so are the Phytophthora species lineages in nurseries the same as the ones that are in wildlands? So beyond species. So I'm showing you that there are Phytophthora species that occur in both nurseries and wildlands, but that's not good enough. So we really need to look more closely at the genetics and on a finer scale to see if they're the same lineages. And the COX-1 region is really good because it's been used to separate out species such as subspecies of Phytophthora alni, which killed alders across Europe, and Phytophthora remorum lineages as well, such as the NA1, NA2, and EU1 lineages. Okay, so it's really good for making these separations. And what I found was that not only was crassimura in the wildlands and nurseries, not only were they the same lineages, the same nurseries that were outplanting to the wildlands, they have those same lineages. So it is going from the nurseries to the wildlands. These are the same ones. And not only that, but the U.S. lineages, they're different from where Phytophthora crassimura was described, which was in Italy. So this is the Italian lineage, and you can see that the haplotypes are quite different. So this is genetic relatedness. The ones in Italy are on this different branch from the ones that are in the U.S., so all the ones in blue. So then we wanted to say, okay, so R is for restoration, N is for nursery, and then I want to look at high rates of methanoxam. How well does the pathogen grow? And what I found was that the ones in the restoration, they're coming from the nursery. They have a nursery phenotype because they can grow in the presence of fungicides. And I'm running out of time, or I've run out of time, so I'll do this quickly. And Mateo had mentioned this as well, but we evaluated the virulence, and we found that, yeah, okay, I didn't have time to sort through my isolates and test out, or the resources to test out whether, you know, find this like really virulent one. I had to take what I got right away and test it out and see if it was pathogenic. presence of significant disease, and our ability to recreate disease on several different plant species was possible, and I think that further spread of any exotic Phytophthora species should be limited through monitoring efforts, the use of mitigation strategies, and the employing of pathogen-free, as best as we possibly can, plant stock for restoration. And we did put out a paper recently about best management practices that can be used in restoration, that can be used for restoration production. I really think that best management practices are only going to work if you do it as a program, where you're looking at all the multiple pathways where Phytophthora can get into that nursery system. Our focus was on sanitation, water management, and soil management. And so this work was all from papers that have recently been put out, so there they are. And that's it.